Hello everyone, welcome to my channel on engineering mathematics. In this video on inverse Laplace transform, I'm going to discuss examples based on convolution theorem. In my previous video, I have discussed convolution theorem in detail with some examples. In this video, I'm going to just recall the statement of convolution theorem and we will see some more examples based on convolution theorem. So let us proceed for statement of convolution theorem. Convolution theorem states that L inverse of phi 1s into phi 2s is given by integral of f1u into f2t minus u du over the limit 0 to t, where f1u is inverse Laplace transform of phi 1s and f2 is inverse Laplace transform of phi 2. It means that whenever you want to find out L inverse of product of two functions, say phi 1 and phi 2, you first find L inverse of phi 1 and L inverse of phi 2 separately, label them as f1 and f2, then find the product f1u into f2t minus u and use it as an integrand of the integral over the limit 0 to t and integrate it with respect to du. The answer of this integral is L inverse of phi 1s into phi 2s. I hope guys you understood this convolution theorem statement. Now we proceed for some examples. In this first example, we are asked to use convolution theorem to find L inverse of s upon s square plus 4 into s square plus 1. Let us look at the solution. First of all, we will choose phi 1s and phi 2s from this function so that the product of phi 1 and phi 2 will become this function. So here I am going to choose phi 1 as s upon s square plus 4 and phi 2 as 1 upon s square plus 1. Clearly phi 1 into phi 2 is the given function. Now let us find out L inverse, that is inverse Laplace of phi 1 and phi 2 separately. L inverse of phi 1 means L inverse of s upon s square plus 4, which is nothing but cos 2t. Similarly, L inverse of phi 2 is sin t. We label L inverse of phi 1 as f1t and L inverse of phi 2 as f2t. Now we will find out the product f1u into f2t minus u. f1u can be obtained by simply replacing every t in f1t by u. So f1u will be cos 2u. Similarly, f2t minus u can be obtained by replacing every t in f2t by t minus u. So f2t minus u is sin t minus u. Now let us simplify this product f1u into f2t minus u. This expression looks like cos A into sin B. And we already have a trigonometric identity of the type cos A into sin B, which says cos A into sin B is equal to half sin A plus B minus sin A minus B. Here you can consider A as 2u and B as t minus u. So sin A plus B will be sin of 2u plus t minus u and sin A minus B will be sin of 2u minus t minus minus plus u. Further simplifying which we get half sin u plus t minus sin 3u minus t. Now let us substitute this product f1u into f2t minus u into convolution theorem. According to convolution theorem, L inverse of phi 1s into phi 2s is integral of f1u into f2t minus u du over the limit 0 to t. We have already found what is f1u into f2t minus u. Let us substitute it over here like this. Now let's integrate this. I'll take out this constant. Integration of sine is minus cos. Remember, you have to integrate this integrand with respect to u. So if you do not find u term in any function, consider that function as constant. Since u is there in this function, integral of sine is minus cos u plus t. Similarly, integral of sine 3u minus t is minus cos 3u minus t whole divided by 3 over the limit 0 to t. Now let us substitute these limits in u. First the upper one. So we get minus cos 2t minus minus plus cos 3t minus t, that is 2t whole divided by 3. Then before substituting lower limit, we put minus sign. So we get minus cos t because 0 plus t is t. Similarly here we get minus minus plus cos 0 minus t. So it is cos of minus t, but cos is even function. So cos of minus t is cos t. Now you can open the bracket and simplify this. So I have opened this bracket. So minus minus becomes plus, minus plus becomes minus. Further simplifying which we get this. Minus cos 2t plus cos 2t by 3 is minus 2 cos 2t by 3, and cos t minus cos t by 3 is 2 cos t by 3. So this is inverse Laplace transform of the given function, and this answer is obtained using convolution theorem. I hope guys you understood this very first example. Now let's go for second example. Once again, we are asked to use convolution theorem to find L inverse of s plus 3 the whole square whole divided by s plus 3 the whole square minus 2 square the whole square. Let us look at the solution. Note that in this function, every s is in addition with 3. So this function is of the type phi of s plus 3. And we have already seen how to find out L inverse of such functions using first shifting theorem. Yes, we are going to use first shifting theorem in this particular example. And according to first shifting theorem, L inverse of phi of s plus a is given by e raised to minus at into L inverse of phi of s. And in this case, a is 3. So L inverse of this function will be e raised to minus 3t into s square upon s square minus 2 square the whole square. Now let us find out L inverse of this function. For that, we are going to use convolution theorem. So let us first choose phi 1 and phi 2. So here I am going to choose phi 1 as s upon s square minus 2 square. Similarly, phi 2 will be s upon s square minus 2 square. Therefore, phi 1 into phi 2 will be this function. Now let us find out inverse Laplaces of phi 1 and phi 2. Therefore, L inverse of phi 1s is equal to L inverse of s upon s square minus 2 square, which is cos h 2t. Yes, you are correct. It is equal to cos h 2t. Let us call it as f1t. Similarly, L inverse of phi 2s will also be equal to cos h 2t because both of these functions are same. Let us call it as f2t. Next step is to find out product of f1u into f2t minus u. So f1u will be cos h2u and f2t minus u will be cos h2t minus u in this way. Now once again, this is like cos ha into cos hb. According to trigonometric identities, cos ha into cos hb is equal to half cos ha plus b plus cos ha minus b, where in this case a is 2u and b is 2 times t minus u. So cos ha plus b will be cos h2t and cos ha minus b will be cos h4u minus 2t. Now in next step, we are going to use convolution theorem to find out L inverse of this function. According to convolution theorem, L inverse of phi 1s into phi 2s is integral of f1u into f2t minus u du over the limit 0 to t. Let us substitute value of this product. Here it is. Now let's take out this half and integrate these functions. Integration of cos h2t with respect to u. What it will be? Yes, you are correct. Cos h2t does not have u in it. So this function is completely constant. So its integration will be u into cos h2t. On the other hand, integral of cos h 4u minus 2t will be sin h 4u minus 2t divided by derivative of 4u minus 2t, which is 4. Now let us substitute these limits one by one. First the upper one in u. So we get t into cos h 2t plus sin h 4t minus 2t, that is 2t whole divided by 4, minus, now substitute 0 in u, you will get 0 into cos h 2t is 0, then 0 in u here we get sin h minus 2t, but sin is odd function, so this minus sign goes out, you will have sin h 2t by 4 in this way. So that minus and this minus is going to be plus here. Sin h 2t by 4 plus sin h 2t by 4 is 2 times sin h 2t by 4, that is sin h 2t by 2. This term as it is. So we declare that this is L inverse of the given function. And this answer is obtained using convolution theorem. Now let's go for next example. We are asked to use convolution theorem to find L inverse of 1 upon s minus 2 into s plus 2 the whole square. Let's look at the solution. Since we have to use convolution theorem, let us first choose phi 1s and phi 2s. Here I am going to choose phi 1s as 1 upon s minus 2 and phi 2s as 1 upon s plus 2 the whole square. Clearly, phi 1s into phi 2s is this given function. Now let's find out L inverse of phi 1s and phi 2s. L inverse of phi 1s means L inverse of 1 upon s minus 2, which is equal to e raised to 2t, because we know L inverse of 1 upon s plus a term is e raised to at. Here a is 2. So L inverse of 1 upon s minus 2 is e raised to 2t. Let us call it as f1t. Now let's go for L inverse of phi 2s. L inverse of phi 2s means 1 upon s plus 2. L inverse of phi 2s means L inverse of 1 upon s plus 2 the whole square. To find its L inverse, we will use first shifting theorem, according to which L inverse of phi of s plus a is e raised to minus at into L inverse of phi of s. Here a is 2. So this L inverse of 1 upon s plus 2 the whole square now becomes e raised to minus 2t into L inverse of 1 upon s square. And whose Laplace transform is 1 upon s square? Yes, it is Laplace transform of t. So L inverse of 1 upon s square is t. So e raised to minus 2t into t is L inverse of phi 2s. Let's call it as f2t. Now we got f1t and f2t. We will proceed for product of f1u into f2t minus u. So f1u is e raised to 2u and f2t minus u is e raised to minus 2t minus u into t minus u. Now let's put this product into convolution theorem. According to convolution theorem, L inverse of phi 1s into phi 2s is integral of f1u into f2t minus u du over the limit 0 to t. Let's substitute this product. It is this. Now further simplifying this, we get this as e raised to 2u, e raised to minus 2t into e raised to 2u into t minus u du. Since this integration is with respect to u, e raised to minus 2t is constant, you can keep it outside. E raised to 2u into e raised to 2u is e raised to 4u. Now we integrate e raised to 4u into t minus u using integration by parts rule. In this, we are going to keep u as t minus u and v as e raised to 4u. So according to that by parts rule, integration of this product is t minus u into integration of e raised to 4u is e raised to 4u upon 4 minus derivative of t minus u, which is minus 1, because t is constant, minus u's derivative is minus 1, into integration of this function, which is e raised to 4u upon 4, and into this 4 becomes 16. Now let us substitute these limits in u. When I substitute the upper limit t in u, we get t minus t, that is 0, into this becomes 0. Substituting t over here, we get e raised to 4t upon 16, and this minus into minus becomes plus. So we have plus e raised to 4t upon 16. Now let us substitute lower limit 0 in u. We get t into e raised to 0, that is 1 by 4, minus minus plus e raised to 0, that is 1 by 16. Further, when you simplify it, you will get this answer. So this is inverse Laplace transform of the given function, and this answer is obtained using convolution theorem. I hope guys you understood this solution completely. Now it is your turn to solve some examples. These are a couple of inverse Laplace transform examples that you have to solve. Their final solutions are given below. Guys, please write me in comment box whether you got these solutions or not. And if you like the video, please click on the like button and share this video among your friends. Next time I will be coming with more such interesting videos. Till then, keep watching. Thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.